Okay, in this section, we're going to be going over some problems involving variation. You might copy down the formulas that I'm going to list on this first page here. We've got direct variation, inverse, joint, direct and inverse, joint and inverse. All of these have different formulas that you'll use in the problems coming up. Direct variation, y equals k times x. Inverse variation, y equals k divided by x. Joint variation, we're going to use z in this instance. Z equals k x y. We're multiplying x and y times k on that one. Direct and inverse. So direct, you've got z equals k times x, multiplying for direct variation, and then dividing for the inverse. We're doing direct and inverse on that one. Joint and inverse, we'll throw in an extra variable. I'll call this one g. G equals k z x divided by y. So whenever you're given a word problem, you'll probably want to change the variables in these formulas to more closely represent the things that are talked about in the word formula or word problems. And we'll look at that here in just a minute. One more thing I want to point out really quickly is that one thing that's going to be talked about is the constant of variation. That's k here. This is the constant of variation. Okay, so hopefully you've got your variation formulas handy and you can look at them as you're going through these problems. I've gone through and bolded the formula as it shows up in the problem. If y varies directly, which is bolded, directly as x and y equals 86 when x equals 11, find y if x equals 31. And then we're going to round almost all of our answers to the nearest hundredth, except for the word problems where they'll give us a little bit of variety in how we're meant to round. But first thing that you'll want to do is figure out what kind of variation we're talking about. Here we're talking about direct. So, which was y equals k times x. And if we're saying y is 86, so you just replace the y with 86 and x is 11. K we're going to leave as k most of the time at the beginning. We'll find k and then we'll plug k in order to find the answer that we're actually looking for. But we know y is 86, x is 11. So going into the next step, all I'm going to do is, in order to get k by itself, since we're multiplying k times 11, we'll just divide by 11 in order to get that k by itself. So we've got k equals, and usually I like to leave my k at least to 4 decimal points. It does say round to the nearest hundredth at the top, but that's just talking about our final answer. Here we're sort of midway through, and for my k, I usually like to use 4 decimal places. So if you put 86 divided by 11 in your calculator, you'll get a pretty long decimal, but I'm just going to put 4 of the decimals, 81, 81. You can round that last one if you want to, although as long as you've got 4 decimals here, it's not necessary to round until we get to the very, very end. So first we're going to find k, which is 7.8181, and we're going to plug that back into the formula. This time, here at the end, it says find y if x equals 31. So still using the same formula, y equals kx. This time we don't know y. That's what we're looking to find. K we know now is 7.8181. And instead of x, we're trying to find y if x is 31. Should be pretty easy with a calculator. Just take that 7.8181 times 31 now, and you get 242.3611. And remember, we are rounding our final answer to the nearest hundredth. The hundredths is the second number past the decimal, and what you'll do is you'll look at the number to its right. If that number is 5 or more, then the 6 will go up. If it's not 5 or more, the 6 will stay the same. So ultimately, when we go to round this, we end up with y equals 242.36. Number 2, if y varies inversely as x and y equals 45 when x equals 2, find y if x equals 28. And again, we're going to round our answer to the nearest hundredth. So we're going to start off writing inversely. Make sure you notice what kind of variation they're talking about. They're not going to bold the word inversely when you see it come up on the homework assignments. Just make sure that you notice it. Inverse variation, y equals k divided by x. In this case, y is 45. K we're going to leave as k, and then x on bottom we're saying is 2. Y is 45 when x is 2. And then we're looking afterwards to find if y if x is 28. So here, all we're going to do once we've got those in, we want to get k by itself. So since we're dividing by 2, in order to get k by itself, we just multiply by 2. Make sure you do that on both sides. So dividing by 2 and multiplying by 2 cancels it out. So we've got k equals 2 times 45 just comes out to 90. Remember, you'll want to, if you've got decimals, a lot of decimals, make sure you get 4 of them. But here, this just comes out to a nice number like 90. So all we're going to do is we're going to plug that back in. So our original formula was y equals k over x. So we don't know what y is because up here we're looking to find y if x equals 28. K we know now is 90. X is 28. And that comes out to 3.21428, and it goes on. But remember, on these ones, we're just trying to round to the nearest hundredth. So we're going to look at the number to its right, and ultimately 3.21. If the number to its right is not 5 or more, then the underlying number, the number in the hundreds place, stays the same. Okay, number 3. If y varies inversely as x squared and y equals 24 when x equals 3, find y if x equals 11. So I want to highlight here that we're varying inversely as x squared. And when we do that, we change the normal variation from variation formula from y equals k over x to y equals k over x squared. So make sure whatever we put in for x, that we square it. So we're starting with y is 24 when x is 3. So y is 24. K will leave as k, and x is 3. Make sure you remember that we're going to square that 3. So we've got 24 equals k over 3 squared, which is 9. And we just want to get k by itself. We're going to find k, and then we're going to plug k back into the original equation. So in order to get k by itself, now we're going to multiply 9. So k equals 216. Now we're going to plug k back into the original equation. Y equals k over x squared. Plugging that in for k now. And up at the top, we're looking to find y if x is 11 now. So y we don't know, k we know now is 216, and our new x is 11, and we want to make sure we don't forget to square that after we've plugged k back in. So we've got y equals 216 over 11 squared, which 11 squared is 121. And that gives us 1.7851, and then so on. Remember, rounding to the nearest hundredth, so you want to underline that 8 and look at the number to its right. If it's 5 or more, the 8 is going to go up. So in this case, 1.79. Number 4, if y is directly proportional to x squared and y is 51 when x equals 4, find y if x equals 15. So direct proportion, y equals k times x. And since we're saying directly proportional to x squared, make sure you do tweak the formula just a little bit. So directly proportional to x squared. So we've got y is 51. When x is 4, make sure you square that. So 51 equals k times 4 squared, which is 16. So we want to get k by itself. Since k is multiplying by 16, we're just going to get rid of the 16 by dividing it. So divide by 16 on both sides. K equals 3.1875. You don't need to bother rounding this. Like I said before with K, as long as you've got 4 digits, you should be fine. So we're going to take that K, plug it back into the original equation, which was y equals kx squared. Make sure you include whatever tweaks that you've made. So that 3.1875 is going in for K. We've got y equals 3.1875, and we're looking to find y if x is 15. So x now is 15, and we want to square it. Make sure you square the 15 before you multiply the 15 and the 3.1875. So y equals 3.1875, and then the 15 squared is 225. And we end up with y equals 717.1875. And here at the end is where we want to make sure to round to the nearest hundredth. So underline the 8, look at the number to its right, and if that number is 5 or more, we're going to round that 8 up. So y equals 717.19. Number 5, if y is directly proportional to the square root of x and y equals 14 when x equals 529, find y if x equals 279,841. So first off, you want to notice that we're talking about direct variation, so y equals kx is sort of your starting point. But in this case, it does say that it's directly proportional to the square root of x. So on the last example, we saw x squared is how it was proportional, directly proportional. Here, the square root of x. So what you're going to do is, instead of just plugging in x, we're going to plug in the square root of x. So we've got y equals, actually, let's go back. Y, they say, is 14 when x is 529. So y is 14. And the square root of 529, square root of whatever x is, which looks like it comes out to 23. So k now, instead of multiplying by the square root of 529, it's multiplying by 23. And then from there, you're basically just doing the same thing that we've done on the previous examples. So k times 23 means we're going to want to divide by 23 in order to get k by itself. And we get k equals 14 divided by 23, 0.0608. And like I've said before, you don't need to bother about rounding k, but just as long as you've got 4 decimals or 4 spaces after the decimal, you'll probably be fine. So you're going to plug k back into our original equation, which is y equals k times the square root of x. Plugging that in for k. So we've got y equals k is 0.0608. And we're being asked at the beginning to find y if x is 279,841. Okay, so I'm going to find out what that square root is. Okay, it looks like it comes out conveniently to just 529, the number we dealt with earlier. So take that times 0.0608, and we get 32.1632. And we're going to keep rounding these to the nearest hundredth. 6 is in the hundredths position. got 3 next to it, so we're not going to change the 6 at all. This is going to be y equals 32.16. Z is jointly proportional to x and y, so we're talking about joint proportion here at the start of this problem. So we'll go ahead and use the formula that was mentioned earlier, z equals k x y for joint variation. And in this case, it says jointly proportional to x squared and y squared. So you want to use your joint formula, but tweak the x and y so that it's jointly proportional to x squared and y squared. So we're given z is 379 when x is 7 and y is 5. So z 379, x is 7, make sure you square that. Y is 5, make sure you square that. So we've got 379 equals k times 49 times 25. 379 equals k times 1225 if you multiply the 49 and 25. Then we want to divide 1225 to get that k by itself, so that cancels there. Divide 1225 over here. And we get k equals 0.3093. And that would round differently, but you just need the 4 decimals again. So we're going to plug that back into the original equation, which was z equals k x squared y squared, and we're putting that in for k. And then we're asked to find z when x equals 6 and y equals 4. So z we don't know. We're trying to find z. K is 0.3093, and our new x is 6. We're going to square that. Our new y is 4. We're going to square that. So z equals 0.3093. 6 squared is 36. 4 squared is 16. Whoop. So z equals, we're just going to multiply all that. So z equals 178.1568, rounding to the nearest hundredth. So it looks like in this case we're going to be rounding that 5 up, so 178.16. Number 7, z varies directly as x cubed and inversely as y cubed. So doing direct and inverse this time. Z equals k times x cubed. That's your direct variation. Your inverse, you're dividing by y cubed. And we're told if z equals 184 when x equals 10 and y equals 6. Z is 184. Don't know what k is. X is 10. We want to cube that, which means it's going to have 3 zeros. And then 6, we're going to cube that. 6 times 6 times 6. So we got 184 equals k times 1 and 3 zeros, 1,000. And then 6 times 6 times 6 is 216. And you can do this a couple different ways. From there, you could do 1,000 divided by 216 and then deal with it from there. I'm going to go ahead and get rid of the 216 by multiplying it. Make sure you do that on both sides. So multiplying 216. On the right, we've got k times 1,000 equals 39,744. And then hopefully it's obvious how to get k by itself on the next step. We're going to divide 1,000. That's going to get rid of the 1,000 on the right. Make sure you do that on both sides. K equals 39.744, and we're going to plug that into our original equation. Z equals k x cubed over y cubed, plugging that in now for k. And we're going to find z if x is 9 and y is 3. So 39.74, whoop. That's k, and then x now is 9. We're going to cube that. Make sure you do that before you multiply. And then on bottom, we've got 3 cubed. So we've got 39.744 times 729 divided by 27. And you should be able to do all that on a calculator in one go. And that should come out to 1,073.088, rounding to the nearest hundredth. So it looks like that 8 is going to go up to 9. Word problems involving variation. Number 8. The distance that a free-falling object falls is directly proportional to the square of the time before it hits the ground. If an object fell 70 feet in 4 seconds, how far will it have fallen by the end of 8 seconds? Leave the variation constant, that's k, in fraction form or round to at least 2 decimal places. Round your final answer to the nearest foot. So here we're not going to the nearest hundredth when we get to our final answer, but setting it up and solving is roughly the same as what we've done in previous problems, aside from just a couple things that I'm going to recommend. First off, we've got direct proportion, so y equals kx. Although I would recommend, since it's a word problem, changing the things. So usually the first thing that's mentioned, in this case, the distance that a free-falling object falls is directly proportional to the square of the time. So instead of y being directly proportional, we're going to say d for distance is directly proportional. K is going to stay k, but instead of y being directly proportional to x, distance is directly proportional to the square of the time. So time squared. Square of the time. And at first it says an object fell 70 feet in 4 seconds. 70, of course, is distance, 70 feet. So that'll go in for D. And 4, of course, is going to be the time, 4 seconds. Make sure to square that. So we've got 70 equals K times 16. And then getting K by itself, dividing 16. Divided by 16, and 70 divided by 16 is 4.375. And as long as you've got, if that's as far as decimals go, you don't need to worry about having 4 decimals here or anything like that. So going back to our original equation that we started with, which was the D equals KT squared, we're going to plug the K in now. So we've got D equals KT squared, plugging that in for K. So distance equals 4.375. And the time, here they want to know how far will it have fallen after 8 seconds. So the time here is going to be 8 instead of 4, which it was previously. So we've got D equals, make sure you square the 8 first, and then multiply times the 4.375. So take that times 64, and we've got 280. D equals 280. Make sure you do round the word problems to the nearest foot. This one, there's no decimal, so no need to round. 5,208 equals k times 2. And you can divide by 2 to get that k by itself. And then k equals 4062. Then plug that back into the formula that we had before. L equals kwd squared divided by L. So 2604 is K. The new width, they say 9 inches wide, 10 inches deep. Make sure to square that. And then 11 feet long. So 2604. Remember to square that 10. 10 squared is just 100. Divided by 11. All right, and rounding to the nearest pound on the word problem. 21305 4.5455. Want to round to that number in front of the decimal place, so 21305, and then since the number to its right is 5 or more, that 4 is going to go up to 5.